This is called the world's simplest motor, and it's really a cleverly designed device that can be used to learn about electric circuits, magnetic forces, and of course motors. We're going to use it here to learn about batteries. As you can see, the motor is designed to be used with D-type flashlight batteries. Also, if you buy one of these, be sure to follow the instructions in regard to scraping the coating off of the wire that you also wind into a coil. The motor turns through the action of magnetic forces, and they depend on current. But you only want current to flow for about half of the rotation cycle, otherwise the forces flip back and forth and you can't maintain a consistent driving force. We've got this one running pretty well with a D-cell battery. We just removed it from the device so you could see how the circuit is constructed. But all batteries are not created equal, and this AAA battery, which has the same voltage rating as the D-cell, can't keep the motor running. You have to at least overcome mechanical friction, and that's not happening. These homemade aluminum air batteries are fun to play with, but this one can't drive the motor either. However, it has no problem driving this small fan. The AAA and D cells will both work here as well, no problem. Let's see if we can understand what's going on using an ammeter to measure the current. Here's the D cell driving the motor, but we've added a multimeter functioning as an ammeter to the circuit. Note how the current varies as the coil spins. That's because contact is made and then broken as the coil spins. If we connect the coil into the circuit directly, along with the ammeter, we can see how much current the coil can directly draw from the D cell. It's getting close to 3 amps. It's only a little over an amp for the AAA battery. We've been using the 10 amp input on our meter, but we had to switch to the milliamp input for the homemade battery. The output is only a few milliamps or thousandths of an amp. So it would appear that both the AAA and the homemade battery cannot produce enough current to drive the coil's rotations. This has to do with force, which in this case depends on current, but also power, which electrically is the product of voltage and current. Mechanically, power is the rate at which mechanical work is done, and to keep a motor running, you need to input energy by doing work at a rate that exceeds the rate that forces like friction dissipate energy. So even though the voltage ratings of especially the D cell and the AAA batteries are the same, their power outputs are not. Most batteries have a power curve that looks like this, and the peak power is inverse to the internal resistance of the battery cell. Commercial batteries are engineered to have low internal resistance, but it would appear that the D cells have less than the AAAs. This makes sense, as AAAs often are used in low-powered devices like remotes, where D cells often power devices like flashlights where power is important.